All right, let's go ahead and get started. I do want to welcome you to the very first chemistry unit of the year. This is Safety, Nature of Science, and Measurement. We're going to call this one Unit 0 because of the fact that we're not quite ready to start formal chemistry just yet. And so we need to take care of some mathematical issues, issues of measurement, talk a little bit about the scientific method, and mainly I want to talk in this unit about safety. So let's start by just kind of settling in. We're going to need something to write with. These notes, by the way, are available on my outreach page. They're not annotated, but if you just want to write on something other than your own notes that's going to give you kind of a head start, that's a good place to start. So here we go, safety. Well, I want to start by talking about something called the Material Safety Data Sheets, or MSDS sheets. So what do we mean by Material Safety Data Sheets? Well, as it turns out, for virtually every chemical, in fact, for every chemical that we'll use in the laboratory, there's something called an MSDS sheet, Material Safety Data Sheet. What we mean by that is that it is an information sheet that contains virtually everything that you could possibly want to know about a chemical. So, for example, let's just say we're dealing with acetone in the laboratory or hydrochloric acid in the laboratory. We're going to want to know, first of all, what are the safety concerns about this chemical? How could it hurt me in the laboratory if I'm not careful? If I spill some on my finger or in my eye, even though I maybe should have had my goggles on. In fact, I should have had my goggles on. I, for whatever reason, didn't have them on, and I found myself in a situation. How do I deal with that situation? Well, the MSDS sheets tell us all of that information. It tells us what the chemical formula is, what the melting point is, the boiling point is, and how to deal with a situation with a spill, for example. So I'll show you examples in class later of what an MSDS sheet looks like, but for now, just please understand that it contains all the information that you need to know about a chemical. So that's what we mean by an MSDS sheet. Now, how about Nfpa? In 1978, legislation was enacted, unfortunately, because of a very severe accident that occurred in New Jersey, and it was called the National Fire Protection Act, NFPA. The National Fire Protection Act made it, by law, a requirement that chemicals that were dangerous have an easily identifiable label on them. And by easily identifiable, I mean this diamond, okay? And you can see that the diamond has in the upper corner a red diamond within the larger diamond, a red diamond. On the left-hand side, you'll see a blue diamond, yellow, and white on the bottom. It has to be in that configuration by law. Red on top, blue on the left, yellow on the right, and then white on the very bottom. And so the red diamond has to do with fire hazards, right? Red has to do with fire hazards. I like to remember like a red fire truck. On the blue side, on the left side, we have blue. I think of a surgeon's scrub. So this is a health hazard on the left-hand side. On the right-hand side, yellow, reactivity. I don't have really a good way to remember that. It's just reactivity on the right-hand side is yellow. And then on the bottom, it is white. Now, the number designations go from 0 to 4, with 0 being the very, very least dangerous, right, for that category, the least dangerous, and 4 being the most dangerous for that category. So, for example, on this one, we see a 2 for a fire hazard. So that's intermediate for whatever chemical this is. It's a kind of an intermediate fire hazard. On the other hand, look at the health hazard. There's a 3 there. So that means there's extreme danger here. It's not deadly, but there's an extreme danger here of some type. We see here on the bottom the specific hazard of water, with a W with a line through it. That means don't use water. Don't add water to this chemical because it could cause an explosion, for example. So special types of situations, for example, if it's radiation, it'll look something like that, for example, in that little space right there. So that's the National Fire Protection Act fire diamond, and we should be familiar with that. All right, so here we go. With regard to safety, there's a couple of rules we need to remember. The first thing is never reach across an open flame. Okay, remember that many times the flame is invisible, so we want to make sure that we don't reach across a Bunsen burner. Next, use goggles and safety aprons at all times. They're going to be uncomfortable at times, but we have to do this because of the fact that you never know when there's going to be a spill, and it could be bad news if you're not wearing your goggles and aprons. So make sure you've got those on. Next, point heating test tubes away from yourself and others. Remember, they can build up pressure, and if they do build up pressure, they can be dangerous if they spurt out of the test tube, and so make sure you've pointed them away from everybody. Next, clean laboratory equipment to avoid contamination. This is not just an issue of keeping the laboratory clean, but it actually can cause a health problem if we don't clean out the equipment adequately. Next, don't use chipped or broken glassware. It can break right in the middle of an experiment and can cause a problem. Always add acid to water. Notice A and A. Add acid to water, never the other way around. Okay? It can get very hot or maybe even explode if you do it the other way around. So add acid to water. Obviously, no eating or drinking in the laboratory. That's critical. These chemicals, if they find their way into something that you're eating or drinking, can be very, very dangerous. So no eating or drinking in the laboratory. Do not place unused chemicals back into the original container. You can contaminate the entire container. And if there is a spill, even a small one, or injury or broken glass or anything, notify the teacher immediately. Don't hesitate. Don't wait. Let's see if it's going to get any better. Just notify the teacher immediately. So really, with regard to safety, it's common sense. Just make sure that you don't do anything that's silly, right? Let's talk a little bit about the scientific method. This is under the category of the nature of science. So we are to be able to define the following: the control, the variable, hypothesis and theory, and then line of best fit. So let's start with something called the scientific method. What do we mean by the scientific method? Well, the scientific method is a procedure for determining the truth. So for example, the first thing we're going to want to do is we want to state the problem. What is it that we're trying to figure out? Then we want to gather information. What information do we already have? We want to form an educated guess, also known as a hypothesis, and then we want to test that hypothesis. And then we want to record and analyze the data. We'll state the conclusion, and then we'll repeat the results. We're going to talk a little bit about the differences between the hypothesis and the theory, but let's just go ahead and take care of that now. What's the difference between a hypothesis and a theory? Well, a theory is has much greater strength. A theory has been extensively tested and is generally accepted, while a hypothesis is a speculative guess. All right. So if you just think something to be true, but you're not absolutely sure, we're going to call that a hypothesis. But if you over and over again test that hypothesis, we're going to call that a theory. Let's move on now to measurement in science. All right. So in science, we measure things. Obviously, some instruments are more precise in measuring volume than others, and et cetera, than others, and some are less precise. For example, if we look at a graduated cylinder, and I've got a photograph of that, and we want to contrast the graduated cylinder on the left with the beaker on the right. The graduated cylinder is a much more precise instrument, right? The little markings on the graduated cylinder are much more precise than is a beaker. A beaker is more of just a container for holding liquid. So if you have to choose between these two containers for measuring with precision, you're going to want to choose the graduated cylinder. And if you just want to hold liquid, you want to use the beaker. So that's that. Now I want to talk a little bit about the difference between accuracy and precision. What do we mean by accuracy? Well, accuracy means how close the values are to the true value, how close they are to the true value. Whereas precision is how close they are to each other. Now let's use the analogy of these three targets right here. We have three targets. I think everybody's had the experience of maybe shooting darts at a target or some experience like that, maybe a bow and arrow or something like that. So let's take a look at this target on the left. For this target, these are accurate. Now, it might not appear to be accurate, but they are accurate because kind of the average of all these is right through the bullseye, right? Right through the bullseye. So they're not right in the middle, but if you kind of take the average of them, they go right through the middle, right? So that's called accurate. Now look at this one right here. These are clustered in this area here, so they're precise. They're close to each other, but they're not close to the target, which is the red bullseye. But look at these. These are accurate and precise. They're close to the target, but they're close to each other, so these have accuracy and precision. Accuracy and precision. Let's look at this table right here. So, here we go. There we go. So, I want to take a look at the following data. It says the following table shows the results of an experiment, and the target value was 12.68 grams. So apparently there was some type of an experiment in which Susan, Ian, Leslie, and Matt are trying to determine what some mass is, right? And so they have various trials. They have 4 different trials. Susan does 4 trials, and she gets 9.408. 11.262, 10.200, and then 12.010 for the last attempt. Ian does 4 attempts as well, so does Leslie, and so does Matthew. Now, we want to ask the question, who is accurate and who is precise? So, I want you to notice this. Leslie's precise, but not accurate, right? Her values are all close together, but they're not the target. Remember, the target was this number here. The target was 12.68, right? So for Leslie, she's precise but not accurate. So the values close to each other but not close to the target. But what about Matthew? Look at Matt. He's accurate and he's precise. The values are very close to one another, but they're also close to that target, right? They're also close to that target. So we're going to say that Leslie was precise but not accurate, but Matt was both accurate and he was precise. All right? So I think that's a good place for us to end on this set of notes. We'll take it up again on conversions on the next one. Thanks. Bye-bye.